Additionally, he has taught several courses at the undergraduate and graduate levels at the University of British Columbia, Lankara College. Um, and um, and as an engineer, Lino has developed machine learning solutions that work in multiple environments, including cloud, edge, and mobile. This experience has allowed him to understand the challenges of machine learning in production, and he's currently working as a computer vision engineer at Equation Innovative Solutions. Lino, please take it away.
Thank you. Thank you so much, Naima. Thank you for the introduction. My name is Lino Coria, and first I'm going to tell you a little bit about myself. I was born in Morelia, Mexico. Morelia is central Mexico, and I attended university there. In Mexico, I'm an electronics engineer, and in Mexico, they make the difference between top left, you can see the picture, one of the pictures of it's a public Institute of Technology, and I went there for my undergrad. And then probably my biggest break in my career happened when I got a scholarship to study in Canada. I attended McMaster University in Ontario, which you see on the top right. And the first semester was very challenging. So any international students that are feeling pressure and concern I just want to say things get better, things get easier. Now I remember it fondly, but back then it was very tough. The first year, I would say. I did my PhD. At McMaster, I worked with Dr. Jim Riley, and he had a lab, the statistical signal processing lab, and I did some work on speech, blind signal separation. So you would have, let's say you were talking on your phone and the background was very noisy. We would find adaptive ways of separating speech from the noise. So very, very interesting research. And then at UBC, I did my PhD under the supervision of Dr. Panos Nasiopoulos and Dr. Rabab Ward. And I learned with them the challenges of having two supervisors, I guess, because they would, one would review my paper, then the other one would review it, then the first one would ask me to show it to them again. But I learned a lot, and I work with images and video. In particular, I work in the topic of digital watermarking, which is embedding an invisible watermark in the content in images or video. I was working on the application was copyright protection, but it can be used for many things. And anyways, that's kind of the work I did as a grad student. Then if you see at the bottom left, you're going to see a very nice campus. That's where I got my first job. I joined academia, and I was working at ITESO University in Guadalajara, I guess technically Tlaquepaque, but Guadalajara, Mexico. And it's a private university, very nice environment. And when I worked there a little bit before, I worked there for a few years, and then I did my PhD, and then I came back there. But I became a father when after my PhD, and Mexico was a different country than the country where I grew up, I think. And I started worrying about, mainly my wife and I worried about our daughter a lot, and we decided that we wanted to return to Canada. And I joined UBC as a postdoc, and I'm going to finish on the story. I just wanted to give you I just wanted to show you that I had done a lot of work in academia before I joined industry. And then here in Canada, I had to sort of reinvent myself, and I joined industry. And I realized that, of course, I had a lot of tools, right? I had a lot of academia had given me a lot of tools, but there were lots of things that I had to learn when I joined industry. I'm going to tell you about a couple of things that I did. One of if you see on the left, I work at a company called BBTV, and this company works with YouTubers. And one of the challenges that you have, and this is some of it is going to sound outdated, but if you go to a YouTube video, if you upload a YouTube video yourself, you are going to get 3 thumbnails recommended to you. And let's say 8 years ago or something like that, YouTube would sort of randomly grab these thumbnails. It would get, say, one thumbnail at the 25% mark, another thumbnail at the 50% mark, and another thumbnail at the 75% mark of your video. And sometimes these thumbnails were not appealing or were not really relevant to the content. So I was working on creating something that would show you relevant and interesting thumbnails. And so it's a computer vision solution that would, go through the video and analyze the thumbnails that would be more interesting. And when thumbnails are interesting, people click on your video. They're more likely to click on your video. So I built a lot of other tools for this kind of purposes to have higher chances of people watching your video. So for instance, the title, if you see in this example on the, as I said, on the left side of the screen, the title is really bad, right? It's one word together. And so what I worked on was a score that would give you a rating, a 1 to 5 star rating on how good your title was. And then it would give you suggestions as how to improve your title, right? So these are things that I work. And I also work at a company called Weave, and Weave creates custom footwear and mostly insoles and sandals, to the best of my knowledge right now. And what you do is you grab your phone and you take some pictures of your feet, and you can see a picture of a foot there, and you can see that there's a piece of paper. And I wonder if you can guess why we have that piece of paper there. The reason is that if this is a letter size paper, we know already the size of the paper. So we can estimate the length of the foot, let's say the width, the length, and all these other parameters. Now, part of my talk, what I want to say in real life, right, is because you build this application, let's say for the US, for Canada, but then when you offer this in Europe, people don't have letter size paper. People have A4 paper. So these are surprises that you get, and that you have to think and to sort of predict things, right? And then for a year, as of today, is a year exactly, I joined EcoAsian. EcoAsian is a company based in North Vancouver, although right now I am home in Port Moody. But EcoAsian has a platform that has a lot of services using data science for growers, for greenhouses. It's very exciting, and I'm working on I'm one of the engineers working on the computer vision side of things. So one of the cool things is we have this 360 virtual walk. So it's like you are inside the greenhouse. You can sort of look around, and one thing I like about EcoAsian is that it acknowledges that the machine is just part of it, but humans are essential to anything, right? So you can see that it says human knowledge and machine precision. And I think this is the best way to look at any machine learning solution. That yes, we have all this data and we can do wonders with the data, but the human knowledge is essential. We should always keep that in mind. Okay, so now I move on to the title of this talk, machine learning in real life. And as I said, I picked a little bit of a controversial title for it. What does real life mean, right? Do you mean that if I'm a student or if I'm a researcher, I'm not doing machine learning in real life? And I think it's different goals, right? So when you're a student, and I'm talking mostly grad students, but I guess this also can apply to undergrad students. When you're a student, you have a big project and you're working on that project, and you are at the same time, you want to understand a lot of the state of the art, right? So you're trying all these different things for all these different applications. So you go for text and translations and computer vision and all this cool stuff, and you try to use the latest things, and you try to use all the different frameworks and things like that, right? And then if you join industry as a researcher, then you're also trying to advance the state of the art. So you are working with say a database that it's a very challenging one and everyone is using this database, this data set as a benchmark, and you're working like that. And when you're an engineer, a machine learning engineer of some kind, and I'm using the term engineer here, someone that is building something that will become a product, right? So something that will be used by hundreds, thousands, or millions of people, right? So this is when you're working as an engineer. Sometimes you do not use the most state-of-the-art neural networks, but you do use the ones that are right for your application. But this doesn't mean it's an easy job. There's a lot of challenges, and I want to talk about these challenges, all these other things that you need to consider that are, I would say, beyond machine learning. So if you know, in the last 5 years, machine learning is everywhere, and you can see that is now virtually everyone can learn about machine learning. You can go to Udacity, and you can go to Udemy, and you can go to Coursera, and you can go to all these online platforms where you can learn about machine learning. Universities are offering it now as an undergraduate program, and a lot of let's say software developers, people that are working in different fields of software, they can go and take this seminars on machine learning, right? Sometimes they just take it can be a 2-week course, or it can be like a micro degree, or I forget exactly the name that are used. Sorry, but so there are these other things. I don't know how you feel about it. I think it's great. I think it's great that everybody understands machine learning, and it's easier to have a conversation with people. It also brings more brains into this, more opportunities for creativity. And I think that especially people that do not come from a machine learning background and learn about box, and they are able to bring up a lot of cool things, right? So I like that machine learning is now for everyone. Now, on the other hand, there's a couple of issues that sometimes I think people are just interested in the latest developments of machine learning, but they don't have the context of everything else that you know that is before, let's say, deep learning. So I just want to say that knowing how to train a model is just the first step, right? And you take these courses and you learn to how to train models, and you know how to test them and do them with different frameworks. And this is essential. Don't get me wrong. This is super important, that you know how to train your models, and that you understand why to do this and why to do that. And you know, that you have all these concepts and all this clear understanding of how to train models. But I also think that, I think the saying is, when the only tool you have a hammer, everything looks like a nail. And I think sometimes that happens. So I would say that every time you're going to work on a new project, or you have a new problem, you think of the problem instead of the solution first. So you think of what is the problem, what is it that needs to be solved, and what are the best ways to solve it. And another way of thinking about it is, do you actually need deep learning? And I didn't go into definitions of things, but a lot of people use the term AI, artificial intelligence, to let's say refer to anything that a computer can do that sort of resembles human intelligence, but it's done by a computer, right? And then from AI, I would say machine learning is a subcategory of that, although most of the time when people say AI, they mean machine learning. And then there's many ways of doing machine learning. And I guess the latest one, and one with amazing results, is deep learning, right? But, and when, like right now, for instance, that I work in computer vision applications, I would say that a lot of problems, deep learning is the way, right? Like for instance, object detection, object segmentation. deep learning I do not think there's another solution better than let's say a convolution neural network, right? Like deep learning is the great job, but there are some tasks of computer vision or other problems that you might have that actually you do not need deep learning. So it's important that you have all these tools, that Hammer is not your only tool, right? That you have a bunch of other tools. And if you know machine learning, you can also ask, do I actually need machine learning? Because some of the time, some problems, you do not need machine learning. Of course, you want to use it and it's cool and it sounds fun, but sometimes maybe you just do some statistical analysis. Maybe sometimes you can have, an old school algorithm. Like in computer vision, there's a bunch of things that we can do that do not require machine learning. We can classify things based on color and based on other things that are already there. The pixels are there. And we really don't need to come with a super sophisticated model. We can just come with like a if, then, else type of solution. So this is my big recommendation. Always think of, do I really need this? Now, something I want to talk about data. A lot of people use, when they're taking a course, either at school or you are taking an online course, usually the data set is already there for you. So you just download the data set, and it can be, I'm talking a lot, I guess, about computer vision applications because that's what I do. And it's so nice, right? Because you can see that the chair is there labeled. There's a bounding box around the chair. There's a bounding box around the wine glass, the bottle, the laptop. And so it's great. It's already built for you. There's all this data, and you just need to train a neural network. But so people, when you're a student or when you're taking online courses, you learn to use this nice data set, right? But when you are working on a very specific project, it's very likely that there won't be a data set for your particular problem, especially if you are, innovating. If you are working with something very particular, maybe you don't have a data set. So this is part of the things you need to consider. How can I get the data? And for instance, sometimes the work you do, for instance, for me, reading data from greenhouses, I can only read data from greenhouses if I am allowed to go and record data from greenhouses, right? So you have to see, how can I get this data, right? How can I make sure that I get all this data? And sometimes real data is messy, and probably most of what you do is working with the data. You can, once I was talking to an engineer that was solving a very challenging problem, but he was saying that he had achieved great success detecting. And when I asked him about it, he said that he had removed all the challenging images, right? So he was working only with the friendly ones, the nice ones. And you don't get to do that in real life, in a real solution. So I would suggest, if you are a student right now, or if you're working on a project for fun, try to work on a project where you have to create your own data set. Do not download a data set from the internet. Try to create one. You're going to learn a lot. You're going to learn first about drawing bounding boxes if it's a computer vision application, or else labeling things. And so I strongly encourage you to work on a machine learning problem that starts from zero, that starts from collecting the data. Now, when I was a student, I really didn't think about time too much. And my, if my PhD takes 3, 4, 5, 6, 7 years, whatever, I just continue to be a student. But that's not the case when you are working in industry, right? When you're working in industry, there are time constraints. Like, you need to have some model working, let's say 3 months from now, or 4 months from now, or something like that, right? There are, of course, money issues. You need, and resources. Like, are you going to train on? Do you have a big, powerful computer that you can use for training? Or if not, do you have the budget to say, go to AWS and spin a machine there and train there? Or do you not have a budget and you can go like use those free Google Colab notebooks to train, right? So you have to consider what are my resources, how much money can be destined for this, and how much time I have. And sometimes time helps you make a decision or of how much, how long can you experiment. You know, you want to try all these different neural networks, but probably you need to wrap it up soon, right? So maybe you get to play with 2 or 3, but not with 15 different neural network structures, right? So all these things are things that you have to start thinking about: time, money, resources. Now, the other thing is your application. Where is this going to be used? Is it going to be a mobile application? Is it just going to be used in people's phones? And then what kind of phones? Even if you're not developing the apps, but your models are going to go there, you need to make sure that you understand what are the limitations. People have old phones. Are they going to be able to use your model? Or does it only work with really new phones, right? Sometimes you're working in the cloud and it's great because you can run more sophisticated models, but the cloud is also expensive. So you have to have conversations about that. And then also, well, if you're working at the edge, you know, you have to think of all the resources that are going to be, you're going to be sharing your chip with a lot of bunch of other applications, right? So have all these things into consideration when developing a neural network, let's say. So it's not the best one, but it's the one that is right for your project. Now, another thing that happens is that sometimes you don't get to work on a new project. If you join a company, sometimes someone had already been working on a project and then this person left. So you have to join and you have to go through the documentation and understand why some decisions were made. Some people are great at documenting. I encourage you to be one of those people that are great at writing, you know, documenting your repository so that if someone comes and has never met you and does not have you as a contact, that this person can read it and replicate and do whatever you wrote, right? But so sometimes you join a company and there's already a neural network that was trained and there's already a framework that was chosen and there's some code with it and you cannot just delete it and start from scratch, right? Because there are deadlines and you need to work. So you need to be prepared for that. You need to be able to, you know, to be able to read it, to understand it, to run it, and to improve it very quickly. And it's important that you have conversations with everybody else at the company about your thoughts and also that you come, let's say you need to be humble, right? Because when you join, sometimes you realize that a lot of great ideas that you had, people already try them. So make sure that you ask and understand why some things, people try some of these things and didn't work. Or if there's something that they haven't tried, then you can for sure bring it, you know, as a new approach. Now I'm going to talk about teamwork and working with your team. And here I have a picture of me and my wife and our 2 daughters. And this is just a little analogy. My wife and I were on the same team, right? And our goal is to make sure that you know, our daughters are happy and have, you know, great opportunities and they just have a happy life, let's say. But sometimes I have different approach at doing things than my wife does, right? So it is hard. Sometimes, you know, she's not happy when I talk about some topics, the way I touch on some topics with my daughters. And sometimes I'm not happy the way, you know, my wife is. I'm afraid to say what, because she might be listening to me. But what you have to keep in mind is that we're both on the same team and we both want the same goals, right? So when you're working with other people, you have to keep that in mind, that everybody wants the best for the product and everybody has different ideas. So communication is key. And this is among your peers. Now, when you're talking to your, having a conversation with your manager, I've worked at different startups and there's different possibilities that you might have in terms of management. The ideal case is when your manager has a lot of experience in machine learning. So he or she are, they are very experienced. They understand the limitations, the challenges, how long it's going to take, and they understand your numbers when you're talking about this and that, and they can offer feedback, and they can also understand the scope of a project and all that. But sometimes when you join a startup company, this does not happen, and your manager might be an expert on something else. I work with people that are great software architects, but machine learning is something new to them. So you need to find a way to communicate things clearly, and to sort of little by little introduce people to the challenges of machine learning. And I'll talk a little bit more about this later, but a lot of people have this misconception that machine learning is like magic, right? And sometimes people don't even think that you need data and you need labeled data. So they might want to do a task and they think it's something trivial. And you say, well, yes, it is trivial, or it's relatively, we know how to do this, right? But we do need data, right? So you need to understand and to be able to communicate, and also to understand a little bit of where your manager is coming from, to be able to have a better conversation. Now, teamwork also involves, I guess, different teams in the company. So you're going to have to work with other teams, and these are things that I never did as a student or as a grad student, right? It was just my project, and that was it. One time I worked with someone else on a project when I was a postdoc, but we would sort of split the sections, and our codes would never like work together, or I didn't have to send her my code and stuff. But in this case, you need to work with other teams, and some of these teams are technical. So for instance, in my current job, I'm part of the data science team, and I need to talk to backend engineers, to firmware engineers, to front-end engineers, and I need to make sure that I communicate, what I need, and that I understand what are their concerns. Especially with the backend engineers, you might, you will have a lot of conversations, and it's very, very, very important that you understand where they are coming from. They're looking at a lot of things that you do not see, right? They're looking at money, cost, time, resources, all these things. Not an expert, like have to.
Are we okay with the sound?
I don't know enough.
Okay.
I know that my internet was shaky for a bit. I apologize for that. Okay, so anyways, you need to make sure you don't feel intimidated if you don't know enough about a topic. Just listen and acknowledge. And then the other thing, sometimes as an engineer, I realize I'm pretty bad at talking to people that are not technical. For instance, in one of my previous jobs, I had to talk to a lot of marketing people, right? And to marketing people, you need to find what is it that they understand, what is it that they want, and what do they think about, what are their goals. And anyways, this is very important that you learn to talk to different people. Now, when you share your results, as a grad student, I learned to do this like the way I have it on the left. Tons of equations and tons of reasons and all this. We used to joke that if you don't have 10 equations, you won't be published, your paper won't be published, and things like that. But it is important that there's a time for that. So if you're talking to your peers, yeah, sure, go with all the full analysis that you did. But especially if, say, you're talking to the CEO, or you're talking to some people that are not part of your team and are not going to give you feedback about, a variable or something like that, that you think Sesame Street. Now, if you have young children, or if you were a young child, Sesame Street has like the letter of the day and the number of the day, right? So think of, what is my number of my talk? What is the number that I want to convey? So try to simplify it as much as you can. So I want to show them that this model is faster than the other model. So that's my goal. This is 4 times faster, right? And that's the number of the day. Or if I want to show that this is, you know, 3 times better than whatever, that's my number of the day. So when you're talking to people, in particular to some people in leadership positions, keep it simple and keep it interesting and think Sesame Street. Now, I'm going to talk quickly about what happens when people don't use your product as expected. And I have this crystal ball here because sometimes the way, that's why I usually say machine learning and I don't say artificial intelligence, because I think now there's too much marketing around AI, and AI is thought of as this magic thing, right? But machine learning, which is essentially what people mean when they say AI, machine learning is, you know, collecting a lot of data, learning from this data, and your results can only be as good as your data, right? So sometimes people don't use your product as expected. Like you have a phone app and people are not following the instructions that you thought they were gonna follow. Or sometimes people are, you know, for instance, let's say you're expecting that there's going to be, like for computer vision, right? There's going to be a video and you need to detect all the people in the video. Well, you have to think, what happens if there's no people in my video? What do I do? Or what happens if it's too dark in this video? Or what happens if the camera is shaky? I only thought of this application if there was a tripod, right? So you have to think about all these things and you have to communicate them to the people that are going to be using your products, right? You have to establish SOP, which I hope I don't say it wrong, is standard operating procedure. So this is what you need to be doing, right, in order for this to work. So computer vision is pretty simple. If your camera is not pointing at the thing you want to actually, you know, identify, if your camera is not pointing at your objects of interest, we won't be able to do magic and predict what is not there, right? And you have to explain why. And I find that a lot of it is with a great user experience. So if it's a phone app, for instance, instead of having a bunch of text instructions, with some creative UX, people will be guided, right? And people will be more likely to do what they should be doing. So you need to. This is not just the machine learning engineer's job. This is, as I said, UX is usually someone else who is designing it, but it's a lot of testing, a lot of QAing, a lot of showing whatever you're building to someone that is not part of your company, or someone that you trust but is not really following the day-to-day. Because when you're working on a project, you assume that everything is obvious, and it is not, right? So you have a phone app that has some machine learning. Well, give it to someone that has never seen that app and see how they use it. I work with some great UX designers, and I've seen them work, right? And it makes a huge difference when they bring in people and they just have them use the app and learn from it. So these are things to keep in mind. Now, sometimes you have to do machine learning for results that are subjective. Like some things are objective, right? Like let's say the problem of count the number of people in this picture, and there's either 10 people or not, right? Like if you say 10, it's either true or not true, or you can say it's close to the truth, right? But sometimes results are subjective, and forget about machine learning for a bit. Here I have 4 pictures, right? And I'm going to ask you, not as a machine learning algorithm, but as a human, if you had to choose one of these images to be used as the cover of an album, a photo album called Disneyland Vacation, right? Which of these 4 images do you think makes a better cover? And all of you are going to think in very different ways. One of you is going to think, oh, the first one on the left, because the 2 girls are like close and we can see their faces and da. But another person will say, oh no, the second one, because I can see Mickey Mouse and it's part of what says Disneyland. Then the third, another person might say, oh, the castle. The castle is like the key, you know, symbol of Disneyland. And then one say, well, but this one the last one has a Disney or a Pixar character. So I think this one is better. So as you can see, sometimes your machine learning solutions do not have a unique answer. So for instance, to go back to this work I did around finding thumbnails for your video that are exciting, are interesting, and are relevant to the content. So what you have to do, for instance, is everybody's going to think of a different thumbnail, but you have the ones that say YouTube recommends by default 3, and your algorithm is recommending other 3, right? So you put them, you scramble them, you show them to people, and you have people, a bunch of people ranking them, rating them. And what you expect is that people will choose your thumbnails more often than they would choose, say, the YouTube generated thumbnails. And then this is not perfect, this is not science, but it's sort of guiding you to understand, okay, subjectively, a bunch of people are picking what my algorithm provides as an output instead of the usual or the traditional thing. So sometimes these are the most challenging things to test, the subjective results. So I know I'm just going over this very quickly, but it's just so you become aware of it and start thinking about this, because you need to improve your algorithm, and you need to improve an algorithm that probably different people will pick different things, but you still need to improve it. Now, the challenge is, once you have your model and you have tested it and it's out there, does it actually work? How do you know? Because people are using it now. It's 100 people or 1,000 people or more are using your model, and you need to keep track of it, right? So you need to monitor your model. There's many ways of doing this, and I don't think I'm super knowledgeable on how to do it, but you have to think of ways of keeping track of your results. Sometimes it can be, let's say, randomly you pick some of them and you evaluate them. Sometimes you have different other models and you compare results between one model and the next. And anyways, if you find an error, if you find something that your model is doing wrong, you need to, well, you have to identify the issue. You have to identify why this is happening, and then figure out how to solve this problem, right? Sometimes the problem is a machine learning problem, and sometimes the problem, as I said, is better UX or explaining the user what to do. So for instance, that problem again of counting people, if they're trying to use the camera late at night and it's all dark, well, you won't be able to count people, right? So you're going to say, okay, we can only count people if we can see them, or maybe we need a different camera. You know, you have to come up a camera that works at night. You have to come up with a solution to your problem, but you have to constantly, once you have a model, it's not there forever, right? You have to constantly keep track of it. And so some final thoughts. I guess I tried in this talk to show you that there are many things that a machine learning engineer has to do, right? Some of them are I would say a lot of them have to do with communication, communicating with your peers, with your manager, with leadership, with other teams, and also with the user, right? With the people that will be your customers, people that will be using your products. So, you know, sometimes I look at the things that my friends are working on that are research related, and they sound very cool. And some, but I would say, I don't want to say that that's not real life. Of course it is real life, but it's a different side of machine learning, right? And what you do as an engineer is to make sure that all this great stuff that has been created can be used in a product that works and a lot of people trust and enjoy, right? So it's an exciting thing to do. And well, that's my talk. I hope I didn't make it too boring, and I'm happy to answer any questions you might have. There's my Twitter handle if someone needs it.
Thank you very much, Lino. That was a great presentation, and especially how you drew examples from real life. That was amazing, and how the importance of data in machine learning, and the example how you related team management with your family. That is really amazing. Thank you very much for such an informative talk. So everyone, if you have any questions, can you please post your questions in the chat so that Lino can answer your questions? I'll just read out the question, and Lino, then you can answer it.
Mm-hmm.
Do we have to put them in the chat or can we ask live?
I think you can ask live as well.
All right. I'll just talk live while other people write in the chat. I know, thank you for the presentation. Love the enthusiasm and thank you for the example. I like them. They're simple enough that we can get our head around and understand it on the spot. One question I had when you were talking about, preparing the data, cleaning the data, so which I kind of usually something called data wrangling. So how much time do you spend on this? Like if you have a regular, let's say that you have your first instance of your machine learning, like how much time do you estimate you spend on data wrangling alone?
Oh, yeah, thanks. Thanks, Elizabeth. I think it all depends on your application or the stage you're at. Sometimes if you're starting a project that is completely new, you need to spend a lot of time on everything, but I would say 50% of the time. And then as you're working on a project that you sort of already know, let's say you work on a project to detect people and count people and you did that, but then you're working on a project to detect, let's say, only feet. Well, you already know about all the neural networks and you just know that you need to collect the data. So then you spend way more time on the data wrangling part. You spend 90% on collecting the data, right? And I would say at least half the time that I spend on a project has to do with data. And then the other thing I didn't discuss is sometimes you have a third party do the labeling for you. Like you hire a company to run all these labeling things, but you need to make sure that they are consistent and that they are correct. So if I can, I like to, this sounds boring and sometimes it might be boring, but I like to look at thousands of images one by one and make sure that they are correctly labeled. You just, listen to a nice podcast or something and you go pop, pop, pop. And it might take you 3 days. Like I spent, like weeks where most of the things I did was just to look at the labels. For instance, sometimes you're working with other people and like different people label different images and the decisions that every person had are different. So for instance, let's say you want to label this water bottle. Some people will do a very tight rectangle here on the label, but some other people will leave a more open one, right? Is that something important to you? Is tight important? Like sometimes having something super tight is really important, especially if after that you're going to do something else to that region of the image, right? So yeah, I spend a lot of time, I would say half or more on the data cleaning, removing things that sometimes you think you have all these images and you realize some of these images are not what you thought they were, right? Somehow there's garbage there. So yeah, I go one by one and listen to a nice podcast. Yeah.
Wow, that's amazing. That requires a lot of patience, I think. So do we have any more questions? You can either unmute yourself and speak it out, or you can just type it in the chat.
Hey, Lino, this is Juan Pablo. So hi, everyone. So I was Lino. Well, Lino was my professor at the college. So he was an inspiration for me. So now I'm working here in Seattle. So welcome everyone to Seattle. So one question, Lino. So what's the advice for a student that start or want to start learning machine learning? So if he wants to start in college or as a master degree, what's your recommendation based on your experience?
Well, so I would say, thank you, first of all, thank you, Juan Pablo. It's so nice to see Juan Pablo and see Jorge, Juan Pablo and Jorge, also students. It's just great to see you guys and to see you succeed. It's great. So I think whatever stage you are at in your life and you want to learn, go learn, right? If you are a high school student, I have seen amazing work done by high school students. Like they're doing all this great stuff with machine learning. So I would say if you're in high school, do not think, oh, I don't know enough math or I don't know enough statistics or programming, coding, right? Like there's a lot of things that I still think I don't know enough, right? But don't let that stop you. and there's many ways you can learn it. So if you're at university, yes, you can. Sometimes I would say just don't make machine learning the only thing you know. Make sure that you have a great understanding of, a very wide understanding of things. As I said, not every problem is solved through machine learning. So you have to to have as many tools as you can. And I know machine learning is very cool. I always look at things that I don't do as really cool, like all the front end stuff. I am amazed by what people can do, or the UX designers. I'm always surprised. And then I have chats with them, and turns out they're super interested in, they say I get to work on the fun projects, right? So everybody thinks of everything else as fun. Anyways, my point is, if you're a teenager and you want to learn, just go ahead and start, right? And start taking online courses. If you are an undergrad, ask if your university offers some machine learning courses. But if you are like an older person like me and you want to try something new, well, just try it. Sometimes there's not enough time, but if you find the time, do it. And the one thing that is very important, and it's sometimes not easy to find, is a mentor. So if you can find someone that can guide you a little bit. So sometimes it's overwhelming. So the good thing is that machine learning is everywhere, right? You search on the internet and you find all these courses on machine learning and all these platforms and resources, but it's overwhelming. You don't know where to start. So if you are able to find a mentor, someone, they don't have to teach you machine learning, but they just have to say, look here, look there, try this, try that, right? So that's a challenge. When you're a student, usually your professors should be your mentors, but sometimes if you're not at university, it's more challenging to find a mentor, for sure.
Yeah, thank you very much, Lino, for that answer. So we have a few questions in the chat. So someone's asking that, have you ever worked on a project that failed because it wasn't commercially viable? What advice would you give to avoid this situation?
Let me think how I answer that. I guess the answer is maybe. But I guess I have worked on projects that are not machine learning related, that are not commercially viable. I work on little projects of my own that ended up nowhere, right? So I'm just going to say that the most important thing is talking to people. So sometimes you have an idea and you think it's the coolest idea, but it's just amazing for you and nobody else. So you have to think, like if I'm going to grab the water bottle again, because it's what I have here. And you think, oh, this is the greatest design for a water bottle. There's tons of water bottles, right? So you have to figure out what's special about this water bottle. And then you have to think, who is this water bottle for? And you say, oh, this is great for children because it's safe and this and that. Well, talk to children. Have a children carry this. Maybe it turns out that it's way too big and too heavy for a child. Maybe it turns out that a child's hand cannot grab this bottle. And it's you are just a bunch of, and your friends are just a bunch of adults building some product for children without really talking to children. So I know I'm answering sideways, but my advice is talk to people, and especially the people that you think of as your users. And it's okay to fail. Have this mentality of, it's not about just success, right? It's about learning, and you're going to learn from the experience. So I would, people say like fail fast, right? Fail fast and move on. So be able to learn and move on.
Thank you very much, Lino, for telling us how important feedback is. So another question is that, could you please tell us about your most favorite machine learning project at Equation?
Okay, so I guess a lot of things I probably cannot talk because there are surprises coming, but I enjoy 360 video, like this video that you can see all over a greenhouse, and that's already in the website. So working with 360 video is really cool.
No, that sounds very exciting. So do we have any more questions?
Sure, I'll have some. I guess, Lino, how transferable is it? So you've worked in a few industries. So how much are those skills transferable from one to the other? And, and where do you have to start from scratch again as you join a totally new field, still within machine learning, but new field?
Yeah. So I find the, let's say, most of it, let's say computer vision, right? So first I was doing a lot of things for YouTube videos. So these were videos of a nature that had all kinds of people and sometimes animation and all these things. And then I moved to feed, essentially. So I work with a lot of feed. And now I'm working with greenhouses, right? And it's looking at a lot of vegetables and different things. So the nature of the application is very different, but the tools in a way remain the same. So you just need to be able to have a understanding of machine learning and to be also able to listen and to listen to your coworkers. But there's a lot to learn, but I think it's fun. Like I started learning a lot about greenhouses and I didn't know anything about plants, or I still think I don't know enough, right? So that is important, that the machine learning part is probably going to be similar. The training, the validation, all these things you do as an engineer to make sure that they are, your project is going well, but the applications are going to be very different. So I say, if you don't have a passion or you do not believe in the sort of mission and of the project you're working on, don't go into that project, because you're going to have to learn a lot about the topic you're covering. So right now, for instance, working with greenhouses, it's all about food, and it's all about fruits and vegetables, and it's you can feel this is for a good cause, right? Like I don't know, I couldn't work on something that I was spying on people, especially people with very little power, like help making the powerful more powerful, and the people with very little power powerless. I could not be able to do that. So it's just, yeah. So I would say the machine learning part remains the same, but the application is different. So you have to make sure that you like it enough so you can go deep into it.
Okay, thank you very much, Lino. So another question we have is that what DL, that is deep learning frameworks, do you use in equation?
So I'm just gonna say that we use whatever is the best solution for our problem. So we can use any framework that is right for the application. And as I said, this is going to be in the cloud. Is this going to be at the edge? Is this going to be on a phone, right? So I would say the best is not to think about what framework do I need to use, but what is the right for what I need. And I'll just say something else. So for instance, if it's going to run on on something made from NVIDIA, what is the best thing for, like, if it's going to run on NVIDIA thing? It's going to be on some cloud from certain company. What is the best approach, right? So just consider all these things.
Okay, thank you very much. So I think this is going to be the last question, and it is for people who want to pursue data engineering. What skills or projects they should learn and do to stand out in the job search? A very important question.
Okay, so I would say try to work on a project from beginning to end, and the beginning part is the data collection, right? And try to turn it into something that people can use and that other people can run, and then you will be able to learn through all the stages of your project. Some people, one time someone asked me, I don't like math. I would say that you have to reframe things, that you have to not think of I don't like math, but you have to think of what are the things related to math that I need to get better at, and how can I do it? What are the best resources I can have? I think math is important, and statistics part of math, I guess, and to, and get better at coding and just doing a little bit of that, and a lot of soft skills, right? Approaching people, being able to ask others for advice and things like that.
Thank you very much, Lino, for being here and for such an amazing presentation. And this message is for everyone that you're going to get a follow-up email. And if you fill in the survey, the form, you're going to be in the draw, which will be for a very famous book called Superior. And you'll also be able to get the presentation. And you can also contact Lino on his email address and his Twitter handle, and he'll be there to help you and to guide you more. And thank you very much. And we'll be having our next brown bag event next week. That is next Wednesday. Yes, and it will be about it's called Assembly: A Tale of Molecular Love. It will be by Sri Gairathi, and she's a PhD candidate in chemistry in University of Victoria. And we really look forward to seeing you again next week. Thank you very much, everyone. Have a great day.
Thank you, everybody. Thank you.
Bye.
We'll open this room until 1:20. If you want to have some more conversation with Lino, you're welcome to stay. Okay. That was great, Lino.
Well, thank you so much for
I would really
inviting.
like to have a conversation with Lino.
Go ahead. Start it.
I'm looking forward to that. So yes, you know what I've been going through in job search since last couple of months. So yes, I've been applying to different places for software development position now, and I'm also applying for data science positions and for software development positions and for image processing engineering positions. So there's a lot going on, and I have had a mentor as well, and I did get a few interviews, but I still think that for example, in the last interview, the problem was that I didn't know about Git.
Okay.
Everything was fine, my interviews was really good, but the problem which I had was related to Git. So that was, I think I need to learn that. So anything which you would recommend, because I don't think that I have any problem with my technical knowledge. I do have all the technical skills and my communication skills as well.
Mm-hmm.
Anything else which you would recommend?
So I mean, sometimes it's you learn by doing, right? So the more interviews you get, make sure you get the feedback.
Yeah.
Right. Feedback is painful sometimes, but if you're getting the feedback, it means that it's something you need to acknowledge and to work on, right? So for instance, if Git, working on, like Git is something that they're mentioning, and you need to be able to, work on it and get better at it. This is something that, for instance, I never did as an undergrad, as a master's student, or as a PhD. I never did version control, because I was the only one working on my code, and I would save it. And if it was super crucial code, I would email it to myself. Like I was just, I feel embarrassed. I feel embarrassed about it, but this is how I worked. And then you understand what it is. And the good thing is that you can find free online courses where you can learn how to use Git. And what makes it better, I guess, is if you work with a friend. Let's say you have a friend and you both work on the same project. So then you get used to having these different branches and to combining your efforts, right? So you get all this understanding. And then I know every time I'm not a software engineer, right? I'm an electronics engineer. So when I see, I guess, people like Jorge, who's still here listening, and he would probably think of what I do like a primitive. Like I like to click on things. Like if I'm committing my code, I like to click on it, and people think you just use the command line, right? And like, why would you be clicking on things? But you find whatever is useful, and just make sure that whatever you hear as feedback, you take that into account. But you also have to rethink is your resume using the right words? Like, am I using the words that they are looking for? Like, one time I was working as a mentor with this guy who had a lot of experience, but he would use the term pattern recognition. So he had done a lot of work on pattern recognition. And no job description would call for pattern recognition. They would use machine learning, right? Or AI. And I was saying, maybe, I know what pattern recognition is, and probably whoever you end up working with knows what pattern recognition is, but maybe call it machine learning. Like, it's not like cheating, because it's essentially, it means the same, right? It's finding patterns, but you just call it this, but now people call it that. So make sure that you're using the words that people use. I had this other problem. I belong at UBC. I was part of the digital multimedia lab. And we would do image and video processing and all these kind of things. But to a lot of people, multimedia sounds like I was doing video editing and so I had to realize that I had to drop the multimedia because it was confusing HR people, right? Like they like, you never work as an engineer. You just were part of this multimedia group.
I know what you're saying exactly.
So those are my suggestions, but just, little by little, I guess, volunteering here and there, you're growing your network, talk to people. Don't be afraid to ask for, feedback. And sometimes feedback is painful, but if you have the right attitude towards this feedback, should be, and it's little by little. Like if I think of, how I started and then what I didn't know, right? And so it takes time and just patience.
I know. I think the last time, actually the first time when we met at the event where Christine was there as well, at the call for papers event, that workshop day. So I think even after that, it's been a couple of months now since we attended the event, and I have learned a lot in these few months. I've been talking to people. I've been applying for jobs. I've been taking a lot of different online sessions. So I think, yes, so you're right. It's always little by little that how you learn and how you, evolve in your technical skills and your communication skills.
And my other suggestion is that you build, and I'm saying this and I don't have it, but that you build a digital portfolio. Make sure you have a place where people can go and look at what you have done. Instead of reading about it, they can go and see, oh, look at this really nice.
I think that's very important. Mm-hmm. Yes, you're right. I need to do that.
Yeah.
So does anyone else has to say anything?
Hey, Christine, we cannot hear you.
The usual thing, right? Yeah. So any other questions? I guess we're good to go then.
Okay. I'm reading a lot of thank yous and gracias. Thanks to everybody that joined and listened to me. Really appreciate you taking the time.
Thank you so much, Lino, and everybody for joining. Thank you, Naima, for hosting.
Thank you for the opportunity.
And I'm going to say goodbye to everyone. I'm going to remove them one by one, and we can stay on if. Ronelle, if we could.
Yes, do you need something from me, Christine?
Yeah, if we could help me, please remove the participants who are still here.
Do you need me here, Christine, for a little bit of?
Yes, just a little bit. Yeah,
sure, I'm happy to stay.
Okay, I'll leave it to you, Ronelle. You're so fast. Yay, done. How was it? How was it, Lino? How do you feel?
Well done.
Thank you. I felt great. The only